Hi, here we have an S factorial equation. X plus 7 factorial over x plus 3 factorial is equal to 7,920. Let's start our solution. Our definition for the factorial we have it is a multiplication of one number with the numbers below that number. So, how to write a factorial for this x plus 7? X plus 7, x plus 6, x plus 5, x plus 4, x plus 3. Here I am going to end up on x plus 3 factorial. Why? Because the denominator we have that is x plus 3 factorial. So we have to end up on the same is equals to 7,920. Now here this x plus 3 factorial and x plus 3 factorial get cancelled. So the remaining expression we have. Now in the next step I will going to rearrange the brackets. Here I will going to rearrange x plus 7 with x plus 4. Here I am going to rearrange x plus 6 with x plus 5 is equal to 7,920. Now here I will going to use the FOIL method to multiply both these brackets. So I will get x squared plus 11x plus 28. And here x squared plus 11x plus 30 is equals to 7,920. X squared plus 11x common in both the expressions. So here I'm going to let t is equals to x squared plus 11x. Now in replacement of this x squared plus 11x, I'm going to write t. T plus 28, t plus 30 is equals to 7,920. Now in the next step, I will going to split this 28 and this 30. T plus 29 minus 1, I will get the same 28. T plus 29 plus 1, so I will get the 30 is equals to 7,920. Now here I will consider this t plus 29 as a and this as b. Same as this, I am going to consider a and this as b. Now I will going to use the algebraic identity, that is a square minus b square is equals to a plus b, a minus b. Here this is a and this is b, so I will going to write this t plus 29, this is a whole square minus, and this 1 minus 1 square is equal to 7,920. In the next step, I'm going to take this 1 to the right hand side. T plus 29 whole raised to power 2 is equals to 7,920 plus 1. T plus 29 whole raised to power 2 is equals to 7,921. Now I will going to take root both the side. So here this square and this root get cancelled. So the remaining expression we have t plus 29 is equals to, and the root of 7,921 is 89. Now here I will going to take this 29 to the right hand side. T is equals to plus minus 89 minus 29. Now here we get T1 and T2. T1 we have 89 minus 29, and T2 we have minus 89 minus 29. So as I solve this T1, I will get T, and as I solve this T2, I will get 118. Here we get two cases. Case 1 is t is equals to 60. And if you remember, we let t as x squared plus 11x. So are we going to write in replacement of t x squared plus 11x is equals to 60. Now I am going to take this 60 to the left hand side. So here this will turn to a negative 60. Now here we get the quadratic equation. So moving on further, first I will going to find out the discriminant. So the formula for the discriminant we have. Here we have B is 11, A is 1, and C is minus 60. So this have 121 minus plus 240. So here I get 361. So the value of discriminant we find out that is greater than 0. It means this quadratic equation have a real solution. So the second case we have t is equals to minus 118. Now here I will going to write x squared plus 11x in replacement of t. Minus 118. Now I'm going to take this minus 118 to the x squared minus 11x plus 118 is equals to 0. So here we get the quadratic equation. Now I'm going to find out the discriminant for this equation. So the formula for the discriminant we have 121 minus 472. So here I will get negative 351. So this less than 0. So here we have no real solution. Therefore, case 2 should be rejected. Now I will going to solve case 1. So our case 1 equation we have x squared plus 11x minus 60 is equals to 0. Now I will going to write the quadratic formula, that is, now I'm going to plug in the values. Now the next expression we get now here as I solve this root I will get 19. Now here we have two x values, x1 and x2. Now the value of x1 we have 8 over 2 is equals to the value of x1 we have 4. And now we're going to solve x2. Here I get minus 30 over 2. As I solve this, I will get negative 15. Now here we get two x values. So here only one is correct. And how we can check? The denominator we have here, to check which x value is correct, I will going to take the denominator x plus 3, that is should be greater than equal to 0. So here the value of x should be greater than and equal to minus 3. Therefore the value of x2 we have can be rejected. Now I will going to use the x1 value, that is 4, and I'm going to verify my answer. Here I plug in the value of x1, that is 4. Now I will going to solve it further. 11 factorial over 7 factorial is equals to 7,920. Now I will going to write the factorial of 11. So 11 times, 10 times, 9 times, 8 times 7 factorial. Why I end up on 7 factorial? Because our denominator is 7 factorial is equals to 7,920. So here this 7 factorial and this 7 factorial get cancelled. So the remaining value we have 11 times 10 times 9 times 8 is equals to 7,920. As I multiply this 11 times 10, so I will get 110. And as I multiply 9 times 8, I will get 72 is equals to 7,920. And here I will get 7,920 is equals to 7,910. So here the left hand side equal to the right hand side. So the value of x we find out, that is absolutely correct. Thank you for watching my video. If you have not subscribed to my channel, please do subscribe to my channel.